And how much of a gamble is there on the fact that you'll get the materials that you want? These things are years, even decades in development. So when you've set a challenge for the universities to provide a material that meets certain goals, can you then set about designing an engine trusting that you'll get it?
That's an extremely good and rather difficult question, and to answer it, I would say it's probably easier to look backwards in time rather than forwards. And if you'd asked me 20 years ago if we would have new titanium alloys that we'd be using in the engines, I'd have said it's going to be very difficult because they're already very well evolved and pretty much optimised. But of course, history would have proven me wrong. We've got a lot of advantages now in terms of modelling and understanding the physical mechanisms behind material behaviour that are actually giving us new insights into the way that materials work, and therefore much more scope for producing really tailored alloys by understanding the physics rather than just doing the evolution empirically.
Do you ever get a huge breakthrough that you didn't expect and have to sort of go back to the drawing board?
Absolutely, and I think some of the relatively modern materials, in terms of intermetallics as an example, where the materials are somewhere between a metallic and a ceramic in terms of their behaviour, that's been quite a big surprise, I guess, for the industry over about the last 20 years, although trying to make those work in a real engineering sense is quite difficult because you pay for the benefit one way or another. So in the case of intermetallics, that's by way of them being rather brittle, which has its own challenges then in both manufacture and in use.
How do you go about saying to universities, this is what we want and this is when we want it?
Well, there's a few key things that drop out of that, and some of them aren't particularly intuitive. One of the prime examples would be that in terms of understanding current product, there's a huge amount of research going on at the moment with well-established alloys that give us a much better insight into the actual physics of how the materials work, and then that gives you the opportunity to actually develop new materials from that. But we do also have a variety of different means by which we can feed that information and those targets into the universities, so that we set challenges basically to the academics and say, in 10 years' time, we would really like an alloy that's got an extra 10 degrees C temperature capability, which may not sound like much, but is an incredible differential in terms of the product, or an extra X% of fatigue strength.